Hello, Yogesh sir.
Yes, yes, Vishal sir.
Sir, I have given the rights.
Yes, okay, okay, sir. Thank you.
Yeah.
Okay, okay, everyone. Sorry, actually there was a power cut at my place, and that's why that somewhat delayed. Anyway, we will start with today's session. I think almost everyone is there. Okay. So today we will continue with packages, everyone. Okay. So the first package we will start with is NumPy. Just let me know. Have you started with Have you started with NumPy? No, right? We haven't started with any package. Last time we discussed about one application. Everyone, can you just confirm? I think we have discussed one application, interactive dictionary last time, or was it a package? Can you just confirm once? Okay, okay. We haven't discussed with NumPy package, right? So we will start with the first package today. That is nothing but NumPy. Okay. Thank you, Nikhil. Thank you. So everyone, just I hope you will follow me whatever I will be doing. Okay, we'll try to cover we'll try to finish today. At least NumPy package we'll try to finish. Other packages you will be able to understand, and it will not take much time. Okay, except Pandas and NumPy, other packages will not take that much of time. So I hope everyone you have joined from the desktop or your laptop actually, and you will be following whatever I will be doing. So everyone, first thing, as in my case, you have seen that like I'm using Jupyter, Anaconda is the Jupyter I'm using. So the packages like NumPy, Pandas, Matplotlib, and Seaborn, these packages are by default installed. Okay, they are already there. You don't have to install it. But still, if you want to install any package, you can install it like this. Just for your like those who are not aware about, I'm telling for them. Just go to Anaconda prompt, and here you need to fire a command pip install and name of the package. Okay, if it is showing you some error, or if it is not installed, or by chance if someone is using some another tool other than Anaconda's Jupyter. Okay, so this is what you can do. Pip install, name of the package is the command to install the package. If you want to install the package from Jupyter notebook itself, you can install it like this. Explanation mark, pip install, and then name of the package. This is also one way. Okay. So in my case, if I do shift enter, it will show me requirement satisfied, because NumPy is already working in my case, and that's why I need to install it. So you can see that it is like showing me star. So yes, it will run, and it will definitely show me that requirement already satisfied. So you can see that, okay, because in my case it's already installed. So everyone, whenever you want to run any terminal commands, you can actually start those commands with explanation mark if you want to run those things in Jupyter notebook. Okay, that is one thing. So everyone, I am going to start with NumPy package. Now, what is a package actually? What package is nothing but it's a collection of programs. Okay, so NumPy is actually a linear algebra library. I can say that it is a linear algebra library. So whenever you want to do some mathematical operations, you can actually make use of this particular library. It's a very basic package. You will see that other packages are actually built on top of this NumPy. And not only even machine learning and data science, even you will and not only even Python, even you will talk about, let's say, deep learning or natural language processing. Maybe in future, if you learn about all these technologies like artificial intelligence, all these things actually come under AI, artificial intelligence. So you will see that for most of them the basis is NumPy, and that's why it is so important for data science and machine learning with Python. Because all of the libraries in the PY data ecosystem, they actually rely on NumPy, and that's why NumPy is one of the main building blocks, and this is incredibly fast. If you talk about fastness, it is incredibly fast. The thing is simple because it is like it has actually bindings to C libraries. C language everyone know, right? So if I ask you a simple question, everyone, if I ask you a simple question, which one is faster? Whether Python is faster or C++ is faster? What can you say, C or C++? Which one is faster, everyone? Python or C or C++? What do you think? Which one is the faster? C++. Nikhil is saying C++. Okay. Dheeraj is saying Python. So everyone, maybe many other people also will feel that Python is faster, but no, it is not like that. C++ is faster actually as compared to Python. But because C, and why am I saying NumPy is faster? Because NumPy has bindings to C libraries, which is faster than Python. And why it is faster, everyone? Why C++ is faster? Because C++ language is actually a multi-threaded language. It is a multi-threaded language. Now, and Python is actually a single thread language. Now, what do you mean by multi-thread and what do you mean by single thread? So, in simple language, if I want to tell you, multi-thread is nothing but, now see everyone, you are aware about processors, right? Maybe some of you are using dual core, i3 processor, i5 processor, i7 processor, or now, right now there is i9 also, and there are different types of processors. So, there are cores, different cores, right, on the processor. So multi-threaded means whatever the cores which are available on the processor, that is whatever the processing power which is available, multi-threaded language is going to make use of everything, and single thread language is going to make use of only single thread, and that's why C++ is faster. And but the thing is that many of the libraries in Python are actually built on top of C++, and that's why number of lines of code in case of this one actually is reduced. Otherwise, NumPy is also built on top of C language. Okay, and that's why it is incredibly fast. That is the reason. I hope you are getting my point. So, as I told you, NumPy is a linear algebra library. Library is nothing but collection of programs which are already written. You don't have to worry about that. How NumPy is written, we don't have to worry about that. We simply need to go import it and use the methods in NumPy. Okay, that is how actually you can make use of NumPy. So yes, we will see. First of all, what we will do is we will try to import it. To import any library, this is the command, everyone. Import NumPy, and we generally use a short name, or we call it as aliasing, or alias, ALIS, or people call it as alias also. Okay, ALIS, short name. Okay, so it's a standard practice to use NP for NumPy, but not necessary. Even one can use their own name also. That's also possible. So everyone just check it. Now in my case it is running. It will not show me any error. You can see that it is running fine. Okay, it is running fine. You can see everyone. Now NumPy library has many built-in functions which are available. It has many built-in functions and capabilities. Obviously one cannot remember everything, but one should know basic and the important things, so that one can go and explore, and on top of that actually one can learn other things. That is the only expectation. So here we will try to learn about some basic things like what is a vector, what is an array, what is matrix, how to generate the numbers with the help of NumPy. So the first thing we'll talk about is how to create NumPy array. Okay, so NumPy array are actually the main way we will use in NumPy, and they are actually come in two flavors, vectors and matrices. So everyone simply remember that vector is nothing but one-dimensional array, and matrix is nothing but two-dimensional array. Let's begin this. Let's suppose I have a list. Okay, let's suppose I have a list named as my list. How to create a list? Square brackets. So something like this: 10, 20, 30, 40, 50. Everyone create this list. Okay, so obviously I should be naming it properly. I wanted to write down list. Okay, this is the name of the variable. So yes, you can check it out, everyone. This is a list. This is a list. So this is how my list looks like. I want to convert this into NumPy array. So simply you need to do np.array and then give the name of your list. That's it. This is how it is looking when it was list. Now it is converted into array. You can even go and assign it to some variable also. Let's say ARR, and then you can go and you can check out ARR, and then you can go and you can check out the type of ARR. It is going to show you array, ND array, one like n-dimensional array. So everyone, np.array is the method to check to convert a list into or anything. not even list, to convert it into array. And see everyone, whatever this ARR is, actually it's a vector, and vector is nothing but 1D array. So remember always 1D array, how to identify it. If it is starting with one square bracket and ending with one square bracket, then it is 1D array. And 1D array is nothing but what everyone? I told you, one dimensional array is nothing but a vector. So this is a vector starting with one square bracket, ending with one square bracket. And two-dimensional array is nothing but a matrix. Remember this. So in case of two-dimensional array, what will happen is there will be two square brackets. So I am telling you because otherwise people will confuse. That's why just understand everyone. Remember this. 1D array is going to start always with one square bracket and ending with one square bracket. Okay. So this is 1D array. Yeah. Let's suppose I have another list, my underscore list 2. So I will give an example of a list inside a list. Okay. Let's say 1, 2, 3. This is first element. This list itself is the first element. 4, 5, 6. Another element. 7, 8, 9. So everyone create this list. It's an example of a list inside a list. This is my another list, my underscore list 2. Okay. So this is an example of a list inside a list. Now I am going to convert this list into array. So array 2 is equal to again what? np.array. And then you can see everyone, my underscore list 2 if I do, and then if I check array 2, now see, it is going to look like this. So it's an example of two-dimensional array. And see, starting with two square brackets, ending with two square brackets, it's a two-dimensional array, and that is nothing but matrix. Simple method everyone. If you want to convert anything into array, just remember that np.array is what you can actually make use of. Numpy.array. So I have given you the example of 1D array and 2D array. Okay everyone, is it fine till this? Anyone in doubt? Are you able to follow me? Like all 14 people who are present, everyone, are you able to follow me? Yes, no? Just let me know so that I can move forward. And let me tell you everyone, Numpy package is very, very important because the things which we will be discussing after this are actually based on Numpy. Okay? Everything is based on Numpy. Whatever I will be sharing with you after this. Everyone just let me know, other people also. Okay, fine. So, okay. So I am able to see 1, 2, 3, 4, 5 people have replied that they are done. Next thing everyone. We will try to talk about some of the built-in methods in case of Numpy. Okay, built-in methods. Now, Numpy we have already imported. There is something, but do you remember something everyone? Range, right? np.range, R-A-N-G. Sorry, not range, only range. Range is a default function available in Python. If you remember it right, if I do range of 5, list of range of 5, it was giving me 0 to 4, 5 numbers, right? 0 to 4, these 5 numbers it was giving me. Similarly, there is something called as np.arange. It is exactly similar to range only. The only difference is that this a is nothing but array. So this was giving me output, let's say in terms of list. This will give me output. np.arange will give me output in the form of array, and it's a 1D array. So if you are not mentioning starting point, it will take by default 0. If I do it like this, np.arange of let's say 10, 20. So it will generate the array from 10 to 19. Just take it everyone. 10 to 19. Okay. So this is the starting point and this is stop. np.arange of let's say if I do 10, 1000. So it will generate from 10 to 999. Just check it. 10 to 999. Anyone can you tell me, is it a 1D array or 2D array? This one. Is it a 1D array or 2D array? Yes, right Rohit, Nikhil. It's a 1D array. Even though it looks like 2D, but it's a 1D because it is starting with 1 square bracket. I hope everyone, you people have got it right. Now see, if I do it like this, np dot range of 10, 100, it will generate 100 numbers. Sorry, 10 to 19, now 100 numbers, 10 to 19. So this is a start, this is a stop. But here if I use step also, so step is nothing but interval, 10 plus 2 is 12, 12 plus 2 is 14, 14 plus 2 is 16 and so on, 98. So this is nothing but step size is given, interval, just take it. Step size I have given as 5. Okay, remember this everyone. This is how you can actually generate numbers with the help of np.arange. Okay. Then there is something called as zeros and ones. If I do np.zeros of let's say 10, it will generate 1D array of 10 zeros. Just take it as 10 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Similarly, there is something called as np.ones of, if I do 10, it will generate 10 ones. Okay. Now everyone, can you tell me, what if I want 10 fives? I want 5 10 times. What should I do? This is how you can do zeros. This is how you can do ones. Can you people tell me, what if I want 5, 5, 5, 5 10 times? What should I do? What do you think, everyone? I want 5 10 times. These are the two methods I told you. What should I do if I want 5 10 times? Everyone getting my point? What if I want 5 10 times? All the 13 people who are present now. Okay, one more person join. Yes, anyone out of 14 people who are present. What if I want 10 fives? What if I want 10 fives here? Tell me yes, no, getting, not getting. Are you clear with the question? Yes, no. Yes, everyone, no idea. Okay, see. Now I want 10 fives, so I can do it like this. np dot ones of. So if you people have thought np dot fives, no, it will not work. I could have asked you, show me 10 times 99. So everyone, you can derive it like this. np dot ones of 10, it will give this one. Just multiply this with 5. You will get 10 5. Or even you could have done it like this also, right? np dot zeros, get 10 zeros first. And then what you do is go and add it here. np dot zeros of 10 and then add it here. So like this you can get anything, not only 5, you can get anything, any number. Any number you can get everything. Everyone, right? I hope it is clear. So np dot zeros, np dot ones, we have seen everyone. Okay. So np dot zeros of, if I want to generate 2-dimensional array of zeros, that's also possible. Just give it like this area, 5, 5. So it will generate 5 rows, 5 columns and 25 zeros it will generate. Just take it. "25 zeros, 2-dimensional array it will give you, starting with 2 square brackets and ending with 2 square brackets. Same is the case for ones also. If you want to generate 2-dimensional array, np dot ones of, let's say I want 5, 9, something like this. So it will generate 45 ones, 2-dimensional array. Okay, everyone, this is possible. I hope that is clear. Next thing, everyone, one more method is there, that is called as linspace. So see, everyone, linspace is very, very important. Lean space stands for linearly spaced elements or evenly spaced elements. It means, let's suppose if I am writing down something like this, np dot lean space of 0 comma 10 comma 3. It means show me three linearly spaced show me three linearly spaced numbers between 0 and 10. So which are the three linearly spaced numbers between 0 and 10? One is 0, another is 10. Linearly spaced means the number which should be at equal distance from 0 as well as a number which is at equal distance from 10. So which is that number? 5. So these are the three linearly spaced numbers between 0 and 10, including both. So this is at 5 units. These also are at 5 units. So 1, 2 and 3. 0, 5 and 10 is what the answer you will get. 0, 5, 10. Linearly spaced numbers or evenly spaced numbers. Everyone, can you tell me what if I want, like, or otherwise can you tell me what will be the output of this one? np dot lean space of, let's say easy one I will do, 0 comma 10 comma 5. Now tell me everyone, what will be the output you will get for this? 5 linearly spaced numbers between 0 and 10. What those numbers will be? So what those numbers will be, everyone? Are you getting my point? What will be the output of this one? I will answer your questions, everyone. What will be the output of this one? Lean space. What will be the output of that? 0, 2.5, 2.5, 5, 0, 2.55, 7.5, 10. This is right. Exactly right. Okay? Yes, Bhargav, right. Now, Rohit is asking, sir, why are we getting full stop? That is not a full stop, Rohit. That's actually a decimal point. That's actually a decimal point. Because by default, everything is in float. That's why. If you do not want this in float, just go here and just type d type. D type equal to integer. You will get like this. You will not get that dot. Same is the case here also. Same is the case here also. By default, it is float. That's why you are getting this dot. Is it clear, Rohit? Your question, whatever you ask. Okay. What do you want to ask, Bhargav? np dot ones of 10 into 5. What do you want to ask? That we actually done it to get 10 fives. Bhargav, is it clear? Bhargav, any question? I think that is clear, right? We wanted to get 10 ones. 10 fives. That's fine. Was that right? Yes. Yes, that was right. So if you have written it like that, when I asked you, yes, that is right. That is what we have done, right? That's what we have done here. np dot ones of 10 into 5 to get this. Okay. So I hope everyone you are clear with this one also, linearly spaced numbers. See, here we can calculate, but maybe if I ask you np dot ones of, let's say 5 comma 10, I want 100 linearly spaced numbers between 5 and 10. This we cannot calculate, right? This we cannot calculate. So lean space can be there. You can make what lean space. It will give 100 linearly spaced numbers between 0 and 10. So linearly spaced means the difference between the next and the previous number is actually same. 5.05 and 5. The difference is 0.5. Add 0.5 in this, you will get 5.10. Add 0.5 in this, you will get 5.15 and so on. So like this you can continue everyone. See, it means show me 100 linearly spaced numbers between 5 and 10 or 1000 linearly spaced numbers between 5 and 10 and so on. You can get whatever you want. I hope other people also are clear, those who are not participating in the communication or this interaction actually, I hope they are also clear with this. I am again repeating everyone, whatever the packages which we will be discussing later on and the applications which we will be discussing, you will see that those will be based on Numpy. That's why the knowledge of Numpy is very, very important. Everyone, after this point, what I will be doing is, I will be sharing, today I will be sharing all the notes with you and I will be sharing assignments with you. You need to solve those assignments. Okay. in the coming 2-3 sessions. Okay, maybe 2 more sessions I think we will require. So in those 2 sessions, just try to make sure that everyone solve those things. See everyone, I am going very slow, so make sure that you ask your questions, whatever you have, whatever the doubts you have. At the end of this particular course, you should be able to develop the projects. That is what my point is. Okay, you should be able to develop the projects. Next thing, after lean space, you might be aware about something called as identity matrix, everyone, right? This is the identity matrix, right? 1 0 0 0 1 0 0 1 0 0 1. Everyone, this is the identity matrix, right? Diagonal element should be 1. Am I right, everyone? Are you aware about identity matrix? Maybe you might have learned that in school or maybe in junior college, let's say. Right? Can you tell me, is it an identity matrix if I write down something like this? 1, let's say, let's suppose if I write down it like this, 0 0 1 0 1 0 1 0 0. Is it an identity matrix? Everyone? Is it an identity matrix? Can you tell me? Yes, no? Okay, Rohit is saying yes. Nikhil is also saying yes, I think, for this question. Right? Diagonal element should be 1. Any other answer, anyone? Yes, so everyone is saying yes. So everyone, let me tell you that this is not an identity matrix. This is an identity matrix. See, in identity matrix, diagonal element should be 1. But which diagonal elements? Where the row number and column number is same. Let's say I am saying row number 0, row number 1, 2, 0, 1, 2. So what is row number here? 0. What is column number here? 2. No, it is not identity matrix. I comma I. Row number, column number should be same. I comma j, where I equal to j. Understand? This is row number 0, column number 0. Row number 1, column number 1. Row number 2, column number 2. Even are you getting? This is not identity matrix. This is the identity matrix. Diagonal element should be 1. But for which positions? Where row number equal to column number, I equal to j. Is it clear, everyone? Generally, forget that. Everyone, can you just confirm that now? Is it clear? That is, like, to you people were saying that that's identity matrix. No, that was not identity matrix. Diagonal element should be 1, but which diagonal elements? Row number, column number should be same. Remember that. In interviews also, it was asked actually, so people are confused with that. Now after this point onwards, I hope people will be able to remember that. How to create the identity matrix, everyone, like this. So see, it is going to give me diagonal elements as 1. But which diagonal elements? Where row number and column number is same. An identity matrix of 5 by 5, and it's a 2-dimensional array, everyone. I want identity matrix of size 10 by 10, np.I. You go and you try to check it out. See. Why are we actually discussing this one? Because from this you can actually build different matrices. You can achieve some other things also. That's why it is very, very important. Okay. So remember this, everyone, identity matrix. Now next thing, everyone, np dot, there is a method called as random, and in random we have something called as rand n. So what is this rand n? Rand n always gives you numbers, or before that I will talk about rand. np dot random dot rand. Everyone remember this rand method. It is going to give you the values from uniform distribution. And uniform distribution means what? It will give values from between 0 and 1 only. That means it's always going to give you positive values. See, if I do it like this, let's say 10, it will give 10 values, but all the values are going to be between 0 and 1. That means positive values. And that is uniform distribution. Maybe in future you will be learning about something called as statistics. So in statistics, maybe you will come across different types of distributions. Uniform distribution, normal distribution, symmetrical distribution, Gaussian distribution, and so on. Or you might have heard about it. So uniform distribution means you will get the values from 0 to 1 only. That means always positive values. So it is going to show me 10 values from uniform distribution. Just take it everyone. 10 values. P dot random dot rand. If I want 100 values from uniform distribution, I can get that. It means all the positive values I will get. Every value will be positive because between 0 and 1, that's why. Everyone remember this. Huh? And every time you run it, see, you might be getting different values. Huh? You will, I am getting some different values and you will get some different values because they are random. See, if I run it once again, next time I will get different values. Just take it everyone. Next time I will get different values. So if I will take a very simple example like this, np dot random dot ran. Let's say 3 values I will generate. So these 3 values will be from uniform distribution. Every time I run them, I will be getting different values. See, every time different because they are random. But every value will be from between 0 to 1. It means positive. Okay, everyone. I hope that is clear. Next thing, np dot random dot. There is something called as rand n. Now rand n will give you values from standard normal distribution. Now what do you mean by standard normal distribution, everyone? It means that, see, standard normal distribution is also called as standard normal distribution is actually a symmetrical distribution. A bell-shaped curve you will get. The values will be revolving around 0. That means on this side there is -1, -2, -3, -4 and so on. On this side 1, 2, 3, 4 and so on. So it means you will get the values from standard normal distribution. Okay, bell-shaped curve distribution will be like this. It means you will get some positive values and some negative values. So if I go and if I run it, maybe from out of these 3 values, some values might be positive, some values might be negative. See, one value is negative and other values are positive. Okay, so values centered around 0 you will get with the help of rand n. If I make it as, let's say, 100, you will get 100 random values. But from standard normal distribution, that means some positive values and some negative values. Okay, everyone. Rand we have seen np dot random dot rand and np dot random dot rand n. Next thing, np dot random dot rand int. Rand int is going to generate random integers. If I do it 5, it will give me random integer between 0 to 4. See, every time I run it, it will give me integer between 0 to 4 including 0. So it can be 3 also, it can be 2 also sometimes. I am just simply running it. See, now I got 3. Now I got 1 also. I will get 2 also sometimes. If I go on running it like this, I will get sometimes 2 also. Definitely I should be getting 2. 0 also I got once again. 4 also I got. So random. Every time I will be getting random. See, I got. Just check it everyone in your case. 2 also you will get if you run it like this. Go on running like this, you will get 2 also sometimes. So np dot random dot rand int has given me random integer between 0 to that particular number. If I give starting point also, let's say 5, 30. From 5, 30 I want, let's say, 10 random integers. That's also possible. See, if I run it once again, I will get different 10 random integers. Different 10 random. So starting point, stopping point, and how many number of numbers you want between this start and stop. But every number will be integer and it will be random because it is np dot random. Okay, everyone. Is it fine, everyone, till this point? All these methods, lean space, np dot random dot rand, np dot random dot rand, and np dot random dot rand int. Any doubt in this? Any doubt till this point, everyone? No doubt. Fine. I hope same with others. Then everyone, we will try to see some more methods. Let's suppose, can anyone tell me what will be the output of this one? np dot, let's say, a range. I will create an array. array ARR I will create. ARR is equal to np dot arrange of 25. Can anyone tell me which elements will be there in ARR? Fast, everyone. If I write down np dot arrange 25, which elements will be there in ARR? Which elements will be there in ARR, everyone? 0 to 24, exactly right. 0 to 24 it is, okay Nikhil? Right, Bhargav. 0 to 24, that is these 25 elements will be there, exactly right. And see everyone, this is 1D array, it's a 1D array. And I will create one more array, that is random ARR, RAN ARR is equal to np dot random dot rand int. Just now we have seen, right? np dot random dot rand int. Let's say I will generate from 0 to 50, I want 10 random integers. So this is how my array and ARR looks like. Okay, so we have ARR like this, everyone, and we have array and ARR like this. Now we will see some methods. Everyone, the shape. What is the shape of the array? We use a method called as dot shape. For one dimensional array, it is going to show you always like this, 25 comma, and there is nothing. It means it's a 1D array. Okay, it's a 1D array. That means there are 25 elements. Same is the case for array and ARR also. You can check it out with the shape. 10 elements are there, it's a 1D array. That's why 10 and comma is there, nothing is there. But what if I want to change the shape? I want to convert it into 2D array. ARR, I want to convert it into 2D array. So you can use a method called as reshape, everyone. Reshape. So how many elements I have? 25 elements. So let's suppose those 25 elements I will represent like this. And now see everyone, 0 to 24, whatever I got, now I am representing all those elements in two-dimensional array. See, it's a 2D array. Reshape method I have used. Reshape. And I will tell you application, everyone. Why are we discussing it? One of the best applications where I can tell you NumPy can be used is images. If an image is there, how image is actually stored on computer? It is actually stored in the image is nothing but what? It's a collection of pixels. It's a collection of pixels. Image is nothing but collection of pixels. Each pixel is actually a value in one cell in the matrix. So if you want to convert 1D image, 2D image, 3D image, 4D image, 5D image and so on, you can do that with the help of NumPy. If you want to create a model where you want to check whether car is present in the image or not, you are going to need NumPy. Because before going and training the model, you need data and machine understand numbers only. For black and white image, it makes use of 0 and 1 in this cells. And for colored image, it is going to make use of 0 to 255. This is how it is. Okay everyone, this is how you can reshape the ARR. If I go and if I check the ARR now, you will see that it is again same. Because I need to save this result. This is just for display purpose. Reshape method and shape method, everyone remember that. Everyone, can you tell me what will be the answer of this one? ARR dot reshape of 4, 5. What will be the output of this? 0 to 24. Oh no. Right. What will be the output of this one? ARR dot reshape of 4, 5. No, it's not reshaped. Can you check it out? It is not reshaped. That is only for display purpose, I told you. See, ARR dot reshape we done 5 by 5. That is only for display purpose. You need to save the result somewhere. But we did not save. What is the output of this one? That was for only display purpose. Are you getting, Nikhil? What is the output of this one? Can you tell me, everyone? ARR dot reshape of 4, 5. Are you people getting my question or not? Yes, it cannot reshape. Array of size 25 into 4 by 5. Value error you will get. Okay. We can't reshape it because you know that total number of elements in the matrix is equal to number of rows into number of columns. So 4 into 5 is 20, but elements are 25. So it will show you error. Right? At least people are checking, going and checking like this. So you are getting some time to execute. At least execute them. Okay, everyone. So you cannot reshape it, everyone, like that, because total number of elements are not cannot be fit into this. But I can do it like this: 25, 1. So see, everyone, it is reshaped. I could have done it like this also: 1, 25. Is it a 1D array or 2D array, everyone? Can you tell me? Is it a 1D or 2D array? It's a 2D array, okay? Even though it looks like 1D, but it's a 2D array. Starting with 2 square brackets, ending with 2 square brackets. Okay, everyone. So we have ARR like this. We have array and ARR like this. Now let's move forward. See, array and ARR dot. I want to find out maximum number of this. So I can find out like this. 49 is the maximum number in my case. Maybe in your case it might be different. Okay, it might be different. I want to find out the minimum from this. Array and ARR dot min. You will get the minimum number out of this. 0 is there in my case. I want to find out the position of maximum and minimum element, index position. So how can you find out, everyone? Array and ARR dot ARG max. This is going to give me the position of maximum element. 0, 1, 2, 3. Let's see whether it will give me 3 or 5 in my case. Let's say it gives me first element or what. So yes, everyone, if two elements are repeated and they are maximum, always remember that it's going to give me position of the first element actually. So 0, 1, 2, 3. Okay. Similarly, you can find out the position of minimum element, ARG min. And position of minimum element is 0. 0 itself is minimum element, right? This is how you can find out it. I hope you are getting. Or otherwise, even you could have done it like this also. NP dot max of array and ARR. This will also give maximum element. NP dot min of array and ARR. This will give minimum element. This is how it is going to work, everyone. Okay, so I hope this is clear, everyone, right? And even if you want to check the data type, you can just do it like this: ARR dot D type. To see what is the data type. In my case, integer 32-bit it is showing. Maybe in your case it is showing integer 64-bit. That's possible. Okay, so these are some of the basic things about Numpy. Then let's move forward with Numpy only. I will be talking about something like indexing in Numpy. Okay, indexing in Numpy. Let's see indexing. Numpy indexing or indexing Numpy. Okay, something like this. Okay, write it down. So indexing, how it can be done? We have seen the indexing of a string, list, tuple, dictionary, and so on. Let's see how indexing can be done. Let's suppose my ARR is np dot arange of, now you understand this, right? 0, let's say 0, 11. I want 10 also, so 0, 11. So this is how my ARR looks like. Now let's see the simple thing. It's exactly the same thing. If I do ARR of 5, so it will give me 5. Slice notation exactly same, everyone. Whatever we have seen in case of string. If I do like this 2:5, so what it will give me? 2, 3, 4, 5, 6. So It will give me what? 2, 3, 4. 2, 3, 4. Because you know that whatever is after colon, it will give me the number before that. So that's what it is going to give me, right? And I think this kind of a thing you have already seen. Actually, this is called as slice notation. Okay, everyone? I hope you understand that. You will be getting index out of range error, right? You never get index out of range error in slice notation. We already talked about it. Okay, I think you understood that. And one more thing, everyone, there is something called as broadcasting actually. What do you mean by broadcasting? See now, if I do ARR2 is equal to ARR of, let's say, 2 colon 5. Now what is 2 colon 5? 2, 3, 4. So 2, 3, 4 will be assigned to ARR2, right? ARR2 will be 2, 3, 4. ARR2 will be 2, 3, 4. Now everyone, if I do ARR2 of, let's say, ARR2 of, let's say, 1 colon is equal to 99. Now what will happen in ARR2, everyone? Can you tell me? This is my ARR2. I add an ARR2 of 1 colon equal to 99. What will be my new ARR2? What will be my new ARR2, everyone? 2, 2, 3, 99 is what Rohit is saying. 1 colon, right? 1 colon I said Rohit. 0, 1, 2. So 1 including 1 it should be, right? Is it like 2, 99, 99 or 2, 3, 99? Can you just check it properly? Yes, it should be 2, 99, 99 ARR2. Okay? And yes, any change in the ARR? What do you think, everyone? Any change in the ARR original array? Any change in this because of that? Yes, no, everyone. Can you tell me any change in ARR? No. Nikhil is saying no. Okay, Rohit is saying no. So that is what is expected, right, everyone? But you will see change in the ARR also. Just see this. So we have taken a small part that is called a slice of ARR. We made a change in the slice of the ARR. We did not make any change in the ARR. But the change in the slice of ARR is affecting ARR also. And this concept in Python is actually called as broadcasting. So remember this, everyone. This is how it actually works. Your expectation was there should not be anything happening to ARR. But yes, ARR will also get affected, and that is called as broadcasting. So if you really do not want to make any change in your original array, I could have done it like this. Now my ARR is already changed. What we should have done is actually we should have taken the copy of this, and then we should have made the changes. Let's say ARR underscore copy is equal to ARR dot copy. We should have done it like this, and then we should have made the changes here. Okay, remember this. So by default, Python supports broadcasting, everyone. Remember that it supports broadcasting. Okay, always remember that. I hope that is clear. Otherwise, people are confused in this. Okay, next thing. Till now we have seen the indexing of 1D array. Now let's try to talk about indexing of 2D array. Not 2D array. This indexing 2D array. Now let me create a 2D array. Okay, so array 2D, or I will just name it like this. ARR 2D is equal to, I will directly pass the list inside of this. Okay, np dot array 2D is equal to np dot array of, let's pass a list inside a list. Sorry, let's pass it like this. Okay, so I will pass a list, let's say 5 comma 10 comma 15, then 20 comma 25 comma 30, then let's say 35 comma 40 comma 45. Okay, so array 2D, you can check it out. It's a two-dimensional array, everyone. We want to understand how to index a two-dimensional array. Now see everyone, if I want, let's say if I want this particular row, complete row I want to fetch. Everyone, one thing you remember always, in case of Python, indexing always starts with 0. So this is 0, 1 and 2. 0, 1 and 2. So if I am saying I want this row, so you can do it like this. ARR 2D of, I want that row only, right? So 1 colon 2, it will give you that row. See, 20, 25, 30. Understood everyone? Right? Now can you tell me what if I want this row 35, 40, 45? Can you tell me what should I do? ARR 2D of what? I want this. First of all, create the array 2D, ARR 2D. Create the ARR 2D. Two colon 3 to ARR 2D of 2 colon 3. 2 colon 3. 35, 40, 45. 35, 40, 45. Yes, right, Manas. That's what we got. Now next everyone. Now like this you can go and you can do like any row you can take. What if everyone? What if I want to fetch? Let's say I want to fetch this column. So everyone remember this. You do it like this. If you want a column, ARR 2D of, you want column, right? Just check which row you want. 0, 1 and 2. That means every row. So always remember, you always give row value. We want all rows, so colon. And which column we want? One column. That's why 10, 25, 40. 10, 25, 40. 10, 25, 40. There could have been other ways also possible. Like I can get this way, this in another way, this in another way. Lot of ways are there. See, everyone, I have ARR 2D. Now I want this row. I can get it like this also. ARR 2D of this row means 0, 1, 2. Second row and all the columns. This is also possible. ARR 2D of second row onwards everything and all the columns. This is also possible. The difference is that whenever you are going to make use of colon in row as well as column, see, before comma whatever is there, that is for row. After comma whatever is there, that is for column. The difference between this answer and this answer is that this answer is 1D array, this answer is 2D array. So whenever you are using colons in rows as well as columns in indexing, the answer, the number of dimensions in your answer are going to be same as the number of dimensions in your original array. Remember this everyone. See, here there is no colon, here there is a colon column. I could have done it like this also. There are a lot of possible answers. So 2 colon, maybe anything, 2 colon 100, comma, I want every column. That's also possible. Okay everyone, this is how you can do it. I hope you people are getting my point. I already told you now after this point onwards everything is going to be based on NumPy, most of the things. Now I got 10, 25, 40 also. So 10, 25, 40 you could have got in any other way. Different way is also possible. So I want all the rows, it means from 0th row to let's say 4th row, all the rows, comma. I want first column, so maybe I could have done it like this also. That's also possible. Now check, it is giving me answer in 2-dimensional array. Right? It is giving me answer in 2-dimensional array. Earlier it was giving me answer in 1D array. So whenever you are using this colon at row as well as column, you will be getting same number of dimensions in the answer as in your original array. What if I want 30, everyone? What if I want 30? ARR 2D of what? 30 I want. 30 I want. ARR 2D of 2 colon 3. Okay, I think it was the previous one. 30 I want now, 30. Yes, everyone, I want 30. What should we do? 30. Remember that indexing starts with 0. Okay, 1 colon 2 comma 2. 1 colon 2, this is what Manas is saying, comma 2. Now, what if I want answer in the same number of dimensions? It is in 1D array, right? I want answer in the same number of dimensions as the original array. Original array is 2-dimensional array. I could have done it like this also. See, now I got the answer in 2-dimensional array. So this is for row and this is for column. Everyone remember that. Before comma, it's a row, and after comma, we write down for column. If you are using colon in both, you will be getting same number of dimensions as the dimension given in your original array. Okay, everyone. So ARR 2D, this is what is given to you. Now the next question, everyone, can you tell me what if I want 2530? I want 2530 in 2 dimensions. Two-dimensional array. I want 25, 30 in 2-dimensional array. So Nikhil is saying, is it the answer, Nikhil? ARR 2D colon to colon comma to 1. 2-dimensional array we want. 2-dimensional array. Okay, that was earlier one, but it was only number. And see, Nikhil, what are you doing? You are indexing first and again you are indexing. Huh? You are doing 2 times indexing. Understand that difference also. I want 25, 30, everyone, in 2-dimensional array. 25, 30 in 2-dimensional array. Tell me how to do it. Manas is saying 1 colon 2, 1 colon 3. Let's say this. Here are 2D of, this is what Manas is saying. 1 colon 2, 1 colon 3. 25, 30. Yes, right, exactly right. So it means you people are getting the points. Right, everyone? I hope. Everyone clear? Okay. What if I want this one, everyone? 10, 15 and 25, 30. 10, 15, 25, 30. Again, I want the answer in 2-dimensional array. Tell me how to do it. 10, 15, 25, 30. Okay, so I think I am getting the answers. Nikhil, is it the answer you said, right? ARR 2D 0 colon 2 1 colon 3 is the answer for this question. Yes, exactly right. Okay, other people, any doubt in this now? Any doubt in this? Okay, fine then. I hope this is clear to other people also. Now, if it is clear everyone, can you answer the simple question? ARR 2D of what if I want to fetch 530? I want to fetch 530. Till now, whatever I was asking you, it was like adjacent elements, right? That's what you people were able to answer easily. Now tell me, how will you fetch? Now do not do it like this. Huh? Don't do it like this. Step by step indexing. We wanted an array, right? We wanted an array format, not any other thing. But what? No, Bhargav, not getting, like not able to get the answer or what? Other people? Okay, now you will also saying no. Okay, fine. Even if it is wrong, no problem. Okay, fine. See everyone, now as I told you, till now whatever the questions which we have seen, those were for adjacent elements, right? Now in this case there are no adjacent elements 5, 30. So see how to do it everyone. ARR 2D of, now I am asking you 5, 30. Can you tell me which row? 0th row and first row. So first of all everyone in separate bracket, write down 0, comma 1. This is for row, and then give comma, and then once again write down for column. 0 column and second column. This will give the 530. Just check it. If the elements are not adjacent, this is how you can get it. This is row now. 0, 530 I asked. So 0th row and first row. 0th index row and first index row. And 0th index column and second index column. That's why I done it like this. Right everyone? So just to get you an idea, can you tell me the answer? What if I want 1535? Try this everyone, 1535. Just to check whether you understood or not. 1535. So Nikhil has written something. Here are 2D 0, 2, 2, 0. Let us see that. Fine, exactly right. Other people, I hope you also got the point. This is the hardest question which is possible on indexing in 2D. That's it. Other than that, like other things, I think you will be able to answer it. Okay, everyone, fine till this. Numpy, in Numpy, right? I hope other people also got this. I said that you will be getting assignment. I will be sending other remaining notes. Numpy notes also I will be sending it to you. Whatever we have done till now, everything I will be sending it to you. Next thing everyone, there is something called as fancy indexing in case of Python. Fancy indexing in case of Numpy. See, let's say suppose I have ARR 2D like this. I will create a 2D array of zeros, 100 zeros. NP or zeros of 10, 10. It should be so if I go and if I write down ARR 2D of like this, you will get 100 zeros, right? Now from this one, what I want to do is I want to create such an array where from this I want to create this array. I want to create an array like this: 0, 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so on till 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay everyone, I want to derive this array from this 0 there. 10 rows, 10 columns are there. It means in 0th indexed row, I want every element as 0. In 1 index row, I want every element as 1, and so on. This is what we want to do. So there are a number of things to do this. See you. Now first of all, we will calculate how many number of columns are there. So I can find it out like this, that ARR2D of, I want number of columns, right? ARR2D of shape, it will give me rows and columns, rows and columns. But I want only columns. It's a tuple. It's a tuple, so I can get 1. So I got number of columns. I will assign this particular value to a variable, let's say array length, ARR underscore length, length. Right? So array length value will be what? 10 then. It will be 10. Right? And then I can write a for loop for some variable I in range of that array length. What I want to do? I want to change this to this. So what is the name of this array? ARR to be. So for I in range of ARR underscore length, that means 10, that means 0 to 9. Okay, what I want to do is in this ARR2D, for every I want to change it to I only. That's it. This is your answer. And then you check ARR2D, you will be getting the required answer. Simple for loop I applied actually. Just check it. This is what we wanted. I just found how many number of columns are there, and then just done that. So from this zeros matrix actually I got this matrix. And again, if you do not want this dot, you can just write down comma float, comma d type equal to float. That's it. By default it is float. That's why this dot is there. Okay. Now I want to understand fancy indexing. So what is fancy indexing? Now ARR2D is like this. So I can do it like this. ARR2D of, let's say 2, 5, 8, 9. So I will get the elements like this. Just square bracket, square bracket. Then see it. So whatever it may be, whatever you enter here, those corresponding rows you will be getting in this kind of a matrix. Maybe 1, 3, let's say whatever it is, 6, 9. You will be getting that one. This is nothing but fancy indexing. Okay. So yes, everyone, this is one thing, and then there is selection also. Something like selection is also there in case of NumPy. Let's say my ARR is np.arange of 1, 11. It means it will give me 1 to 10, right? 1 to 10. So if I write down ARR greater than 5, so it will show me whatever the condition is satisfied for all those things, it will show me true. And for the other things, it is going to show me false. Yes, if this condition is satisfied. But I want to see the actual values. So you can go and you can index on that particular condition. And then you will be getting the actual values to satisfy this particular condition. This is how you can see it. Okay. Maybe you could have written something like this also. X equal to, let's say, 8. Okay. And if I write down ARR of X greater than, ARR greater than X. Same thing, 9 and 10 you will get. Because X value is 8. Whatever the value greater than 8 in ARR, just show me that. That's why it is showing me this. So this is nothing but selection area. Okay. Now any doubt anyone in this, in NumPy? No? Then the last point we will talk about in case of NumPy is NumPy operations. NumPy operations. I hope till this point everyone is fine. Okay. So NumPy operations everyone. Now I will create array ARR once again. ARR is equal to np dot arrange. Once again let's say 0, 10. So it will be giving me 0 to 9. So ARR is like this. Do all the arithmetic operations on ARR as you can see. ARR plus ARR. What it will do? 0 plus 0, 0, 1 plus 1, 2, 2 plus 2, 4, and so on. 9 plus 9, 18. It will add everything. See? I can do something like this. ARR minus ARR. Everything is going to be 0. Obviously. I can do ARR into ARR. Multiplication. But everyone, if I do ARR divided by ARR, what will happen here? What will happen here? 0 by 0 division will be there. 0 divided by 0 will be there. And 0 divided by 0 is actually not possible, right? So you will be getting something like runtime warning, but for others it is going to calculate the answer. Right? Sometimes something like divide, true divide, something like that you will get actually. You will get a runtime warning. See, yeah, invalid value encountered in true divide, because this will be what? 0 divided by 0 and NaN you will get, not a number. For all others you will get 1, 1, 1, 1, 1. That's how it is. Even the something similar to this one also. 1 divided by 0 will be what? Infinity. So for first one you will get infinity, and for others it will calculate the answer. See, INF infinity. Even raised to operation also you can do, right? Raised to operation is possible, yes. ARR raised to, let's say, 3. It will find out the cube of every number. Right? Sorry, it is multiplication, right? Star star is raised to. See, it will find out the cube of every number. Okay, and then there are some universal array functions which are possible, like square root, exponentiation. So np dot square root, if I want to find out the square root of every number from ARR, that's just possible, square root of every number. I can find out np dot exponentiation, e raised to of every number. E raised to 0 is always 1, so it will give me answer 1 here. So e raised to 0, e raised to 1, e raised to 2, and so on. This is the value of e raised to 1, 2.7182, and so on, right? So yes, everyone, this is how you can find out. Even you can find out log also, np dot log. But maybe I think log of 0 is infinity, right? Minus infinity, something like that you will be able to see. Let's see minus infinity. I think I have already shown you np dot max mean. That's also possible. Np dot max is going to show you max of ARR, right? Np dot mean will show you mean of ARR. Numpy. And yes, you can even find out np dot sign and all those things, operations also you can do. Sign 0 is 0, right? So yes, all these are the universal array functions everywhere. Just check this. Now, based on all these things, everyone, I am going to give you one exercise. I will be sending it to you today, okay? See, everyone, I will be sending you some files now. There will be exercise, let me show you. You need to solve this. I am going to send the link in the group, everyone. I am going to send the link in the group for assignments and notes. The assignment which you need to solve, I will show it to you actually. It's an easy assignment. and you will be able to solve it easily. In case of NumPy, okay, this assignment I am sending now. Like today, as I told you, I will be sending all these files. So I will be sending all these files to everyone. You need to solve these questions. Answers are given, like output is given. You need to write down the answer here. Okay. I will recommend that don't make any change in this file, because otherwise your this output will be gone. So just see the question from this and write down the answer in separate notebook. So you will see all these are questions as assignment. So everyone, I hope you will solve it. NumPy exercise is the name. So solve that. Okay. I will be sending it to you. Then the next package I am directly going to start everyone, that is Pandas, because we have some time, so we'll start with Pandas also. So maybe in coming week or maybe in coming 2 sessions we'll be able to finish everything. I told you I'm ready to go for extra session also. Okay. Or even we can take gap, you can solve assignments and then once again we will meet. That's also okay with me. Because same thing I applied for last batch actually, so they actually come up with very good projects only. Really good projects those people came up with. Okay. Next package I am going to start is nothing but Pandas. Everyone, Pandas is actually called as extremely powerful version of Excel, Microsoft Excel, because it can actually automate all the things which can be done with the help of Pandas. So whenever you want to go and whenever you want to, let's say, deal with some data, it can be from CSV file, Excel file, XML data, you can actually make use of Pandas. Okay, and Pandas are actually built on top of NumPy. Pandas is also library. How to import it, everyone? This is very important. Pandas is very important. Import Pandas as PD. Even Pandas can be used for visualization also. But for visualization, we will be discussing separate packages, and that is nothing but Matplotlib and Seaborn. Okay, Pandas also can do visualization, but we'll be using separate packages. So everyone, this is how you can import Pandas. I already imported NumPy. So in case of Pandas, we will start with something called as series first, and then we will move to something called as data frames. Okay, and then we will talk about something called as group by, then merging, joining, all these concepts we will be talking about, concatenating. Then we will talk about data input and output in case of Pandas. Data input and output. That means how to deal with Excel, CSV, text data, XML data, HTML data, and so on. Okay, everyone. So see, what I will do is I will create a list called as labels. Labels is equal to, let's say, a comma. You also created, everyone. I don't know how many people are following me, because I can see people are generally lazy, but I will recommend that you do it. Okay, we are here even on Sunday also for you, everyone. So we care for you, right? Like, so that at least you should also go and type it, if I am saying. So everyone, labels is A, B, C, D, E. This is the list I have created. Then I will create a list with the name my list. And yes, if you people think that you are already aware about these things, you know these things very well, let me know. I will skip this part. That is also fine with me. 10, 20, 30, 40, 50. Specifically for those people who are not typing these things. I will create an array. How to create the array? np.array. This is what we have seen, right? So I want to create an array I want to convert this list 100, 200, 300, 400, 500 into series. Then let's say I have a dictionary also. So dictionary is, let's say X is a key and value of the key is, let's say 1000. Y is a key and the value of the key is, let's say 2000. Then X, Y and Z. Seed is a key and then value of this key is, let's say 3000. Whatever you want you can actually give. I am just giving any random numbers. X, Y, Z, W, let's say. And this is having key as 4000. And let's say one more. Let's say R. Okay, and then give the value as 5000. Okay, so everyone, this is my list labels. My list is also our list, right? This is also another list. Array is ARI is the array and D is a dictionary. This is what we have created. Those people who do not type it, like I am sending it in the chat box also for you. Everyone, make sure that you type this thing. I am again and again repeating. Now everyone, what we are going to discuss is, we are going to discuss the first thing, that is nothing but array. That is nothing but series. What is a series, everyone? In simple words, I can tell you series is nothing but it's exactly similar to one-dimensional array. One-dimensional. See everyone, in Pandas, we are going to talk about series and data frame. These are two important things. In simple words, if I want to tell you, this data frame is nothing but a table, simply a table. A data frame you can think of as a table. Okay, a data frame you can think of as a table, and series you can think of one column from that table. So this is a series, and this whole table is nothing but data frame. So collection of series is nothing but a data frame. Now how to convert a list into a series? Just check it. Pandas dot s should be uppercase. I want to convert my list into series. That's it. If you press shift tab here, we'll be able to see all the arguments which are available. See, first argument is data, second argument is index. So if you directly write on it like this, it means it is data, and run it. Now see, everyone 10, 20, 30, 40, 50 was there in my list. So this list is converted into series. If it is converted into series, it looks like this. If you want to really check it out whether it's series or not, Control C, then go here, check the type of that whole thing, and then you will be able to see that it's a series. I could have done it like this also. Pandas dot series of, I could have done it like this also. Data equal to my list. Yes, that's also possible. Or even I could have done it like this also. Pandas dot series of data equal to, what is that name? My list. And maybe I can give the index also. Let's say index is labels. What is labels? Labels is another list. So everyone, remember that this is actually data and this is the index by default. If you are not giving the index, by default Pandas will take 0, 1, 2, 3 as 4 as the index. And if you are giving the index, then it will take that index. So now in this case, my index is going to be A, B, C, D, E, and values are going to be 10, 20, 30, 40, 50. You can check it. Right, everyone? See, index is this and data is this. Even if you would have written it like this, index first and then data next, that will also work. But in that case, you will have to give what is index and what is data. This will also work the same. Or otherwise, if you do it like this, pandas dot series of, simply write down my list, that is this data, and label is the index. So it will by default understand that first argument is always data, second argument is always index. So this is index by showing A, B, C, D is the index and this is the data. Even you could have used any other thing also. Even I have an array also, right? What is ARA? ARA is an array. Label is a list. Label is a list. I could have used this one also. So pandas dot series. Now I want label as data and array as index. index. That's possible. See, it's also a series. Okay, I want to convert dictionary into a series. So you can do it like this. Panda dot series of, in case of dictionary, just give D. So in case of dictionary, whatever is the key, that key will be used as an index, everyone. Remember that. This key will act as an index by default in case of dictionary. Just check it in. Just check it out. Okay. So in case of dictionary, always remember that key is going to act as an index. If you try to give something else as an index, it will give you NA, simply NA or NAS. Let's say I am trying to use that as an index, so it will show data as NAN, not a number. So this is how you can actually convert a list, array or a dictionary into series. And a collection of series is nothing but what? Collection of series is nothing but a data frame. We will see data frame also. One more thing is that, let's suppose I have a list of some functions like sum, length, okay, or print. This is a list. But see, everyone, even series can understand that these are actually built-in functions. Series can understand easily that these are actually built-in functions. See? Built-in function sum at index 0, it's a built-in function sum, built-in function length, built-in function print. So yes, series is actually that much. What you can say, it is actually Pandas package is that much smart that it can understand that. Okay, so this is one thing, everyone. Another thing is, even you can actually do some operations based on indexes in case of series. Let's say I have a series as series 1. Series 1 is equal to pandas dot series. Data, let's say, is 1, 2, 3, 4, let's say 4, and index is let's say some values, let's say USA. Okay, these are the values. Maybe Germany or USSR. Okay, these are indexes. Any index you can use, Mumbai, Pune, whatever you want. This is my series 1, everyone. Okay, maybe I think I need some bracket. Comma, bracket. Okay, it should have been in the list actually. I given the list. Even this is my series 1. My series 2 is USA, Germany. Instead of this USSR, let's say I will make it as Italy. Okay, and then so this is the series 1 and this is series 2. Now everyone, you can see USA, Germany are present here also. Japan is here also. But USSR is here, which is not here. And Italy is here, which is not here. So if I go and if I try to add these two series, then what will happen is, this index is not here. Sorry, this index is not here. And this index is not here. So what it will do is, USSR, so 1 plus 1, it will be 2. 2 plus 2, 4. But for USSR, 3 plus NaN, 3 plus missing, 3 plus null. Any arithmetic operation with null always results into null. So for USSR, it will get null, and for Japan, for Italy, it will get null or NaN. And why it is arranged like this? Because it's alphabetically arranged. Just take it, everyone. This is where I got not a number, and this is where I got not a number. Everyone, I hope you people are able to understand this. This is series 1 and series 2. I am simply trying to show you the operations based on indexes. Okay, I think I copied the result actually. Wait a minute. Control. This is series 1. Those who are doing, this is series 2. Even I will send notes for pandas also, everyone. Okay, I will send notes for pandas also. Just make sure that you refer that. Any doubt anyone till this point? Any doubt? Because now I will try to show you data frame. Okay, no? I hope till this point everyone, other people are also okay. Even if there is some doubt, it will be clear when you will refer the notes which I will be sharing, because those will be self-explanatory again. But again, make sure that once you get those things, you execute it. Numpy exercise will be there, Pandas exercise will also be there. Okay, let's try to see data frame in case of Pandas. As I told you that data frame is a concept actually in case of Python, data frame concept is actually taken from R language. I don't know whether you are aware about R or not. But there is one more language which is generally used in statistics or even in data science and machine learning also, and that is nothing but R language. So if you know Python, you can easily learn R. It's a very easy language actually. Generally, in data science and machine learning trainings, like when I take conduct those classes and trainings at our organization actually. So for freshers, for students, for experienced people, I talk about both the languages, R as well as Python. In machine learning and data science trainings, machine learning, data science, AI, deep learning or NLP trainings, I talk about that. So R as well as Python. So if you know Python, you can easily learn R. You cannot compare R and Python actually, both of them they are good, but domain wise Python is going to overtake R. Otherwise both of them they are good. Okay, so everyone, now what is a data frame? Let me give an example here. How to create a data frame. See everyone, now in case of series we have seen there is something called as data and there is something called as index. So here we have data, index and column also. I told you data frame is simply a table, that's it. So I hope you remember this, right? np dot random dot rand n generate numbers from standard normal distribution 5,4 to generate 20 numbers, some positive, some negative, right? Because it's a standard normal distribution. So this is what I am going to make use of my data. This is what I am going to make use of my data. Okay, that's why I showed you separately. Next thing is, see everyone, can anyone tell me what will be the output of this A, B, C, D, E dot split? What will be the output of this one, everyone? Can anyone tell me? A, B, C, D, E dot split. Let me check how many people are there. Okay, fine, good. Everyone is there. What will be the output of A, B, C, D, E dot split? Anyone? Yes, it will be list, right? It will be a list. Same is the case for W, X, Y and Z. So everyone, I am going to use that A, B, C, D list as a row and this W, X, Y, Z as my column and this as my data in a data frame. See, I will create a data frame now. Pandas dot data frame is the method to create the data frame. To this, the first argument I can pass data. So what I will do is I will simply pass this as my data. Copy it, paste it here, comma. Then index. Index is equal to, I will use this. Copy it and paste it here. Okay. And then finally, columns is also here. Columns is equal to, I will do this one. And then now see everyone, this is what is your data frame. Okay everyone, I will also send it to you in the chat box. Just check it. this is what is your data frame. Even you can go and you can actually assign it to some variable, let's say df, any variable you can use, even your name also. So df, you can check the type of this, and then you can see that it's a data frame. A, B, C, D, E are the indexes and W, X, Y, Z are the columns. Okay, and then we can see indexing. df of W, I want only W column. That means this column, this whole column W. This is what you can do. Just check the values again. Obviously, in your case, you might be able to see different values because we generate the data with the help of random. Okay. I want to see two columns, so you can index it like this: square bracket inside square bracket, and then I want to see, let's say, X column as well as I want to see Y column. Sorry, not X. Yeah, X and let's say Y column. Both I want. So see, you can see both the columns. Both the columns means all the rows. Obviously, all the rows. This is one way. Even this way is also possible. Dot notation also is actually used. But the preferred notation is square bracket notation for indexing always. Remember this. But this is also one notation possible. Okay. And if you want to add a new column in data frame, that's also possible. See, if I want to add a new column, let's say named as new, df of new is equal to, I can do something like this. Let's say df of x plus df of, let's say, z. So new column I want to add in data frame df, and now you can see new added. Just check it. New is added here. You can check it once again. df, see this. This is what I have. Now you can add a new column. Okay, in data frame. In data frame D. Then, if I want to drop that, I can drop it like this. df dot drop. What I want to drop? I want to drop a column called as new. But everyone, if I run it like this, only it will show me error. It will show me error. Now the reason, if you remember, do you remember something called as axis? We have seen in case of Numpy at the end, axis. Can anyone tell me what should be the value of axis for row and column? Anyone remember that? What should be the value of axis for row and column? Yes, for column it should be 1. Axis should be 1. Okay. So everyone, by default the value of axis is 0. If you want to check it, go here, shift tab. Make the practice everyone. See, axis value is 0. 0 means row. But do you want to drop the row? No. You want to drop the column called as new. And that's why I will write down axis equal to 1 because it's a column. Now you can see that this new column is not there. Just check it. But after this, if I check df once again, you will see the new column once again. That means this dropping operation is not done permanently. If you want to drop it permanently, everyone, you do it like this. df of df dot drop new comma is equal to 1 because column, and you need to make this of this particular option in place equal to true. This option as true you need to make. That means you are dropping it permanently. Just check it. Now it will not show. In place equal to true means what? Do this operation permanent. Make permanent change. Okay, like this, if you want to drop a row, you can. df dot drop, you can actually drop a row also. Let's say I want to drop a row D. Row D. So you just need to do axis equal to 0. You will no need to do axis equal to 0 because by default axis is 0. See, row D is dropped. A, B, C and E is there. No D. Okay, but if I have to check it out df now, it will be there because we have not done it permanently because we need it. I just wanted to show you. Okay, this is how you can actually drop row and column. And then next thing is everyone, what if I want to see the row? So So df.loc you can do, and you can actually see a particular row. Row A, see complete row A you will be able to see. Df.loc of, let's say I want to see row E. Yes, you can see that row E. Complete row E you can see. Just take it. Okay. So LOC stands for location, everyone. And this is the difference between a series and a like we can say Numpy array. In Numpy array you can actually not index on the basis of label, but in series you can actually index on the basis of label. And yes, in data frame also it's possible. So see, you can actually index rows like this. Okay, and there is one more method, everyone. See, if this is my data frame, these are my indexes, right? Location I can use, and I can actually index on the basis of A, B, C, D, E. But always remember, everyone, in the backend there is always one more index, like this. That means if I want to see this 0, I can do indexing on the basis of that index 2 also. But for that you need to use ILOC, df.iloc of you need to use 2 and then run. See, you will be able to see 0. You will be able to see 0. ILOC stands for index location. Okay, ILOC stands for index location. Okay, everyone. I hope it is fine for everyone. ILOC, LOC, everything. Even what if I want to get a particular value? Let's say I want to get this value. I want to get this value only. I can get that. Simply do df of what is that row? B row and white column. So B row and white column. That's possible. Just make sure that you give like obviously this should be df.loc location. Row and white column, so you will get that value. White column is this one. If I wanted this one, I could have written Z. What if everyone, what if I want A and B row and W and Y column? A, B row and W and Y column. I want 4 values. What should I do? A, B row and so A, B row means these rows and W and let's say Y. So that means I want this value, this value, this value and this value. So yes, it's possible, everyone. df dot same thing, LOC. Simply need to give the brackets properly. I want a row AB, so you give it like this. How to remember it? Just practice. That is the only solution. Repeat the same thing whatever I have given you, or the notes whatever I will be sharing with you. Just simply repeat those only one way. A, B and which column? W and Y. Even you don't have to do anything. You will be able to do a number of things if you just try to repeat whatever I am giving you. So see, I got those 4 values. Okay, and yes, you can even do conditional selection also. If I write down df greater than 0, I will get true, false, where this condition is satisfied, where it is true. So let's say this value must be greater than 0. See, this value is less than 0, that's a false. But I want to see actual value, same thing, df of df greater than 0. You will be able to see actual values which satisfy this condition, otherwise any not a number which do not satisfy the condition. Right? I want to see everything where W is greater than 0. So df of W, wherever it is greater than 0, I want to see only that data. That's also possible. Copy this and index on the basis of that then. Yes. So it will show you only those rows where W is greater than 0. This row and this row. BD. Because at those places only W is greater than 0. Okay. And even you can go and further index it. You can go and you can further index it on and on. Let's say from this I want to see only Y. Obviously that's possible. Let's say from this I want to see Y as well as X. So show me only that Y where W is greater than 0. Or show me that Y and X where W is greater than 0. So give square bracket here. And Y comma X also you want. Complete one more square bracket. So show me only those Y and X where W is greater than 0. Okay, so this is all you can actually do it. So even df of W greater than 0, I can add one more condition also. Like this. df of, let's say I want Y greater than also 0. So you can go and you can check it out. Maybe df of, let's say df of Y greater than 0. Okay. And maybe I should use a parenthesis. Even you can use all those logic operations also, whatever we have seen earlier. So wherever W is greater than 0, Y is greater than 0, it's going to show you those things. Okay, I think, okay, it should be actually like this. So df of Y greater than 0 and this one df of W greater than 0, right? So df of W greater than 0, that is fine. df of W greater than 0 and df of Y greater than 0. So I think I'm missing, it's fine. Okay, I think I'm missing one bracket here. So I want to see what df of W greater than 0 and then here it should be like this. Okay, because this is one condition. df of W greater than 0 is square bracket. So show me where W is greater than 0 and Y is greater than 0. So only that row is B, where W as well as Y is greater than 0. Okay. Is it clear everyone now? Is it clear, any doubt? Obviously I told you that once you get the notes, you try to go through all those things. I will be sharing remaining notes now, so that it will like we will be speeding up now. For other packages you will not require that much of time. So I will be sharing Numpy Pandas notes, Numpy exercise, Pandas exercise, Matplotlib notes, Matplotlib exercise, Seaborn notes, Seaborn exercise. Assignment I am interested. This is what we will be, like I will be sending it to you today. I will be sending the link in the chat, like in the WhatsApp group. Okay. Any doubt anyone till this point? Anything you want to ask till now? Whatever we have discussed about that. Anyone any doubt? No? Fine. Fine. Last part was little bit confusing. Not confusing actually. It is, I told you, right? When you will do it, Nikhil, when you will do it yourself, you will get it. Maybe if you still have some difficulties, just try to refer the notes, whatever I will be sending you, do it and then come up with the questions in the next session. Is it fine, Nikhil? Come up with the questions in the next session. Because see, 2 hours is not sufficient actually. Let me tell you, even when I conduct the training actually, training is like for 1 month, 1.5 months only for Python. It's like that, right? So obviously it's going to happen. But still I'm moving very slow. Okay? I'll be sharing the notes everyone, like those will be self-explanatory. And we'll go through that. Okay, so I think 1, 2, 3, 4, 5, 6 people are fine with this. Maybe I don't know about others. I don't know whether they are listening to me or not. Anyway, I don't know how you people take this, whether you do it only for your attendance purpose or what, I don't understand. But anyway, at least some people, if they are doing it, that is fine. I told you that, see everyone, we are actually I have my own startup named as Bharat Soft Solutions. So we do training as well as we do development. So maybe in future, if some of you are interested to work with us as interns, sometimes we provide a paid internship also. That means you don't have to pay actually, we will pay you. We will assign a task to you people and you will have to complete it. You will be getting the guidance, the required training, and you will have to do it in team. Okay, so definitely you can do that. You can actually think about that. So by keeping those things in mind, you learn these things actually. Okay, everyone. That's why I see even like if you really want to see whatever the things I am explaining you, most of those things even are given actually on my YouTube channel also. I think last time also I told you this, and even you will be able to find out like lot of applications which I have created with the help of Python. You can actually create a lot of things with the help of Python, lot of things. So many things you will find R, SQL, Unix, Hadoop, Python, machine learning, deep learning, data science, AI, a lot of videos you'll be able to find out on this. So even if you want to go and explore, maybe you can explore here also if you want. Right? It's your choice actually. Definitely you can go for that. Okay, everyone. I hope it is fine till this point. I hope you people are getting. I send the attendance link also. Just copy that link and let me know if you have any doubt, anything, anytime. You can put in the group or WhatsApp me. Okay, so yeah, I will be sending you the notes. As I told you, I will be sending you the notes. So you can expect it till evening or maybe within 1 or 2 hours we can expect it. Okay, everyone, then we'll stop it here for today and we'll meet in the next session. Right? So bye everyone, take care. We'll meet in the next session. Let me know if you need.